Hi everybody. Had a request for the test quiz 12 to be done. So that's what I'm doing right now. And we've got an equation here, cosine of 2x plus sine of x. Now, when I look at the formula sheet here, I've got sine x here. I had three choices here. I think I'll do the one that just has sine squared in it. And I'm going to replace cosine of 2x with 1 minus 2 sine squared x, and then plus sine of x equals 0. So we just have the one trig function here. And if I rearrange this, I'll have negative 2 sine squared x plus sine of x plus 1 equals 0. And I'm tempted just to multiply the whole equation through by negative 1. Just multiply both sides. And negative 1 times 0 is 0. And then that way I have a positive for my lead coefficient, and it does not change the solution. So 2 sine squared x minus sine of x minus 1 equals 0. All right, I am going to factor that. I'm going to put 2 sine x in one set of parentheses here and sine x in the other. And then I'm going to play around. I got a negative 1 and positive 1 that I need to put down here, and since this is negative, I want to put this one negative because on the outside I'll have negative 2 sine x, and on the inside I'll have positive 1 sine x. So that factors. And then the zero product property says 2 sine of x plus 1 equals 0, or sine of x minus 1 equals 0. And if I subtract 1 and then divide by, well, I got 2 sine of x equals negative 1, then divide by 2. I've got the sine of x equals negative 1/2. And, okay, where is the sine negative 1/2? Negative 1/2, that's going to be over here and over here. And I think if you're looking at the unit circle, this is pi, so it's like 6 pi over 6. This is 7 pi over 6. And this is 2 pi, which is 12 pi over 6. Right before that is 11 pi over 6. So I've got here, so far I've got x is 7 pi over 6 and 11 pi over 6. But I haven't done this one yet, this part of the equation. Sine of x equals 1. Where's the sine equal to 1? Right up here. And I think sine of pi over 2 is 1. If you come down here, sine is negative 1 down here, so just this one. So here's my three solutions to that equation. Now, the next one, number 2 here. Tangent of x over 2 minus sine of x equals 0. So, what I've got for tangent of x over 2, we've got a couple ways we could go about this, but I think I'll try to use this identity here. Depending on the quadrants, I've got positive and negative square root of 1 minus cosine theta over 1 plus cosine theta, then minus the sine of x, that's equal to 0. Okay, I'm going to take just a moment. All right. Actually, I'm going to use a different identity that we have, and it's not actually on this formula sheet. So let's see, we have sine of x there. I think I will go 1 minus cosine x over sine x. We have two choices there. I'm going to use that one. And then I'm going to multiply. I want to get just one denominator here. So I'm going to multiply this one by sine x over sine x. Sorry about the crampedness there. And I got 1 minus cosine x minus sine squared x over sine of x, and that's equal to 0. And so, let's see, I'm going to change this. I'm going to actually just multiply both sides by the sine of x. And then I just have this numerator. 1 minus cosine x minus sine squared x equals 0. And I get 1 minus cosine x minus 1 minus cosine squared x equals 0, because sine squared x plus cosine squared x equals 1, and then you just solve for sine squared x, you'll get that. Well, let's get this simplified here. 1 minus cosine x minus 1 plus cosine squared x equals 0. And that cancels and that cancels, cosine squared x. So I'm going to write it cosine squared x first, minus cosine x equals 0. And I'm going to factor GCF. Cosine x is in both of those. So I have cosine x minus 1 equals 0. So the cosine of x is equal to 0, or cosine of x minus 1 equals 0. Now, if cosine of x is 0, that would be here at pi over 2, and here at 3 pi over 2. So I'm going to write my solutions over here. Pi over 2 and 3 pi over 2. And if cosine of x minus 1, that means the cosine of x is equal to 1. And that happens here at 0. 2 pi, we go to 2 pi, but do not include 2 pi. So I have these three angles for the solution on that one. All right. 30 minutes is 30/60ths of a degree, which is 0.5 degrees. So we're talking 67.5 degrees that we're trying to find the sine of. And if I were to double that, that would be 67.5 times 2 is 135. And that is on our unit circle. So if I take the sine of 1/2 times 135 degrees and use the half angle formula for that, for sine, and 67.5 is in the first quadrant, so it's going to be positive. I will do, that will equal positive square root of 1 minus cosine of 135 over 2. Okay, now cosine of 135, there's 90 and 45. That's this one right here. Cosine over here, it's negative, so that's negative square root of 2 over 2 right there. So 1 minus negative square root of 2 over 2 divided by 2. That is square root of 1 plus square root of 2 over 2 divided by 2. I'm going to make 1 and into 2 over 2. So I have, I'll come up here now, square root of 2 plus square root of 2 over 2. That's the numerator. Let me come down here, and that is over 2. And so that's dividing by 2, so I'm going to just multiply that by 1/2. So I've got 2 plus the square root of 2 over 2. There's my numerator. And instead of dividing by 2 with that denominator, I'm going to multiply by 1/2. And that is the square root, or 2 plus the square root of 2 over 4. Now that's going to equal the square root of 2 plus the square root of 2 over the square root of 4. And then my final answer for the exact value in simplified form is square root of 2 plus square root of 2, and that's over 2. So there's my answer there. Now, tangent of 7 pi over 12. I think I might use the half angle again on this one. Half of 7 pi over 6 is 7 pi over 12. So the tangent of 1/2 times 7 pi over 6 is equal to, I've already done a half angle here. I'll just keep that one. I'll keep the one we did up here. 1 minus cosine of 7 pi over 6 over the sine of 7 pi over 6. And the cosine of 7 pi over 6, that's this one right here, is negative square root of 3 over 2. The sine is negative 1/2. So I got 2 over 2 plus square root of 3 over 2 over negative 1/2. And now I'm looking at 2 plus the square root of 3 over 2 times, it's like dividing by 1/2, I'm going to times by negative 2 over 1. And I'm going to cancel that 2 with that 2. Now I still have the negative, and the 1 is basically disappeared. So I'm going to make this distribute. Negative 2 minus the square root of 3 for my exact answer there. Okay. Number 5. Use the law of sines to solve, if possible, the triangles. If two solutions exist, find both. Okay, now this one, we had been talking about A, B, and C, but A had always been the given angle, and how to compare that. And this one kind of slipped us up a little bit. We'll put B right here. And here's A, point A, and I'm going to go 25 degrees. So kind of go like about like this. And this is .2 units long. And let's see. here a little bit. So there's A. Now B is 4 units long. This is 25 degrees. And here's point C. All right. I think if you look here, that we could draw the 4 here as well. So this one does have 2 triangles. And the height of this H value here, if it's smaller than 4, that means we are going to have 2, this is an ambiguous case, there's 2 triangles that can be described with these. So we got to find both of them. And H is, here's the hypotenuse, opposite, let me just solve that real quick. Sine of 25 equals H over 6.2. So 6.2 times the sine of 25. 6.2 times sine of 25 is 2.6. Okay, so that's smaller than the 4, which means we've also got another triangle right here, with that would be 4 as well. So let's go through this then, and let's solve for this outer triangle first, if we can. So I got the sine of 25 over 4 equals the sine of A over 6.2. So 4 sine of A equals 6.2 times the sine of 25. I'll divide by 4. The sine of A is approximately, let's do that calculation, 6.2 times sine of 25 divided by 4, 0.6551. Okay, and let's do the second inverse sine of the answer of 0.6551. I'm getting 40.92 degrees. Okay. So A is 40.92 degrees here. And then after that, we take, we got to find C. We got to find angle C and side C here. So in order to do that, I'm going to take angle C is 180 degrees minus 25 degrees minus 40.92 degrees. 80 minus 25 minus 40.92. That's 114.08. So there's angle C. And then side C, the sine of 25 over 4 is equal to the sine of 114.08 over C. And C times the sine of 25 equals 4 times the sine of 114.08, and these are degrees. And I'm going to divide both sides by the sine of 25 degrees. And I'll have C is approximately 4 times sine of 114.08 divided by sine of 25 was 8.64. Okay, so one triangle, the missing parts are angle A is 40.92 degrees, angle C is approximately 114.08 degrees, and side C is approximately 8.64 units long. There's one with the rest of the triangle. Now we also have, I'll kind of redraw this, C here and A here. So I'm moving the A from here to here. We've got to figure out that angle. And then B's still here. This is still 25 degrees. This is still 4. And this is still 6.2. This is 40.92 here, the supplement of that. So 180 minus 40.92, that's 139.08. 139.08 degrees. Okay, so let's put that in for A. 139.08. And then 180 minus 139.08 minus 25 is 15.92, and that's how many degrees are right there, 15.92 degrees. Angle C is 15.92 degrees, and then we got to solve for C right here. And I'm going to use law of sines there. And I'm going to use the sine of 25 over 4 equals the sine of 15.92 divided by C. So C times the sine of 25 is equal to 4 times the sine of 15.92. I'll divide by the sine of 25. I'll divide this by the sine of 25. C is approximately 4 times the sine of 15.92 divided by the sine of 25, 2.596, 2.60. All right, so there's the two triangles for that ambiguous case. All right, this one, I'll put A here. I'll put B here. I'll go at 150 degrees or so, whatever that looks like. Probably more than that. There we go. A little wider angle there. Okay. Now A is 10 units long, so that's this side right here. This is point C. C is 20 units long, so I don't have a good drawing. 20 is smaller than 10 in my drawing, it looks like. And this is 150 degrees. Now, one of the things we need is side B, and that's the first thing we can get. So B squared equals A squared, which is 10 squared plus c squared, which is 20 squared, minus 2 times 10 times 20 times the cosine of b, which is 150 degrees. So b squared is approximately 10 squared plus 20 squared minus 2 times 10 times 20 times the cosine of 150. And I'm getting b squared is approximately 846.41. I'm going to take the square root. Second square root. Second answer. I've got it in there. 29.09. So b is approximately 29.09. And then rather than use law of cosines again, I'll go to law of sines since we have an angle and its opposite side given. So the sine of 150 degrees over 29.09 is equal to the sine of c over 20. And 29.09 times the sine of c is equal to 20 times the sine of 150 degrees. I'll divide by 29.09. I get the sine of c is approximately 20 times sine of 150 divided by 29.09, 0.3438. And I'm going to take the inverse sine of that, and I'll have c, and the inverse sine of this, and I'll have the measurement of the angle. So second sine, I'm just put that answer in since it's there. I need 20.11. C is approximately 20.11 degrees. And then angle A, is that all? Yep. Angle A is 180 degrees minus 150 degrees minus 20.11 degrees. That's 30. 30 minus 20 is 10. 10 minus 0.11 is 9.89 degrees is what I'm getting there. Okay. That's number 6. Number 7. From a certain distance, the angle of elevation to the top of a building is 17 degrees. So I'm going to draw my building. I'm going to draw the ground. I'm going to draw a point and note that the angle of elevation here is 17 degrees. If we move 50 meters closer, I'll move right around here. This is 50 from here to here. The angle of elevation is 31 degrees. Find the height of the building. We want the height of the building here. I got 31. This is, we'll call that a right angle. And I think I've got it. If I have one more piece of information in this triangle, I'll be able to find it. Now, and I think I'm going to try to use this side as that one more piece of information. So that's going to require me to work with this triangle right here, and I can get this angle. 180 minus 31 is 149 degrees. These are supplementary angles. They add up to 180. So 149 and 17 is 166 degrees, which gives me a 14-degree angle here. So I'm going to use law of sines and solve. I'll call this just x. This x right here. Sine of 17 degrees over x equals sine of 14 degrees over 50. So 50 times sine of 17 degrees equals x times the sine of 14 degrees. I'll divide by the sine of 14 degrees. And I got 50 sine 17 close divided by sine 14. I'm getting x to be approximately 60.42 meters. This is 60.42 meters. And then the height here. This is a hypotenuse. This is the opposite of 31 degrees. So I'm going to use SOHCAHTOA. The sine of 31 degrees is equal to the height of the building, h, over that hypotenuse of this triangle, 60.42. And when I multiply both sides by 60.42, I'm going to get h is approximately 60.42 times the sine of 31, 31.12 meters for the height of that building. Okay, number 8. A triangular parcel of land has lengths of 725, 650, and 575. Find the measure of the largest angle. Okay, I'm going to draw this one to be 725. Okay, I need to draw these smaller. So let me kind of go here and here. It's not meant to be a right angle. And make this one 650 feet. This is 725 feet, and this is 575 feet. Okay, the longest side, the angle opposite that would be, I'll call this A, call this B, and this is little b, call this C, and this is little c. All right, so I'm going to solve for this angle, and I'm using law of cosines. I think side, side is a law of cosines problem. So I'm going to be using the A. So 725 squared equals 575 squared plus 650 squared minus 2 times 575 times 650 times the cosine of A. Now I'm going to have to do the rest silently because I got a class coming in, but I'm just going to finish up and you'll be hearing the commotion. I will, yeah, I'll get that. Okay. I just need to finish this up real quick.
Or that you're a thief. We need a lot of crowds. Best time of the year, I want to be everyone. I hate walking the halls and stuff. I said, yes, you know, I was in the fat. All the players you're not fat. You're just skinny. That wouldn't be She's like, yeah, I only share my details with other people that have my experience. So all of us are like sick of that crack. I'm gonna need to like walk back into the class. I should do that. I should walk into his class and like, what if you follow me? I should get a ball pass notice for DUI. Get like a notice, like underarm. If I were to replace, like I'd have to get a new paper. I would require it. I'll put $2 and stand right at the edge of the infield and outfield and go like this and say like, thank God, something. Or thank God that it's over or something. Or something like really embarrassing. Like, only $1? I work for the dietitian college. Like that's half my salary. He's like, you should do it for $1. And I'm like, probably humiliate myself for $1 or.
Okay, guys, that is it.